afternoon all. Today we will discuss about oscillations, especially simple harmonic motion. I think you know about simple harmonic motion. Simply it is called as SHM, right? So the conditions for SHM it is the body must be in to and fro motion about main point, and second quality of the SHMET is the acceleration of the particle is directly proportional to the displacement and as well as in opposite direction. And third quality of the SHM is the acceleration always towards mean point. If these three conditions obeyed, that is called as SHM, simple harmonic motion. Right? Now consider a particle which is in uniform circular motion, right? And this is a diameter, it is also diameter. The radius of the particle of this circular it is taken as A is a radius, and of course it is also A. Now a particle is a diameter x dash, and one more diameter is y dash, and the center of the circle is O. The particle it is in uniform circular motion, uniform circular motion, particle in uniform circular motion. What is the meaning of uniform circular motion? The angular velocity, nothing but omega, is constant. Angular velocity is constant, that motion is called as uniform circular motion. Now its projection, see, particle P you can consider the projection at point O. Now the particle in uniform circular motion, that is moving in anti-clockwise direction, and at this position shadow at this point, let us say taken as n. Now the particle at y, so shadow it becomes point O. Like continuation, if the particle completes one rotation in anti-clockwise direction, its projection oscillates O to n, n to O, O to, let us consider n dash, one more point, and n dash to O completes one oscillation. Particle completes one rotation, and its projection completes one oscillation from O to n, n to O dash, O dash to, sorry, O, and O to n dash to O. This is one oscillation is completed. Now I'm redrawing that same circular. This is N and this is O, that particle at point P, and the radius it is taken as A. The angle at the center it is theta. What is theta? It is angular velocity. Angular velocity theta can be written as omega into t. T is at an instant time. Now draw a normal. This is a normal. Okay, one more normal. O to n, the distance it is taken as y, the displacement of the particle or the projection is taken as y, right? So the value of pm also becomes y. So from this triangle OPM, from triangle OPM, writing the value of sine theta. What do you mean the sine? It is nothing but opposite by hypotenuse. Opposite it is nothing but y. Hypotenuse nothing but radius, which is the value equal to a. So y is equals to a sine theta, but already we know what is the value of theta, which is omega t. Therefore y becomes a sine omega t. This is the basic equation or fundamental equation in simple harmonic motion, which indicates displacement of SHO, simple harmonic oscillator. Now, what is its velocity? According to definition of velocity which is equal to the rate of change of displacement dy by dt. So v equal to dy by dt. So I'm substituting the value of displacement, that is v is equals to differentiation d by dt of y, which is equals to a sine omega t, which gives the, after differentiation, a omega cos omega t. It's the velocity of SHO, right? Now I'm calculating acceleration. So acceleration definition, we know the rate of change of velocity, that is a equal to d by dt of velocity. Just now we derived a omega cos omega t. I'm substituting here a omega cos omega t, which gives acceleration value a equal to minus a omega square sine omega t, and this equation also written as, in terms of displacement, that is a equal to minus omega square y. In the beginning already I discussed with you, is a uniform circular motion means omega angular velocity which is constant. Therefore the same equation can be written as a proportionally to minus y, nothing but the condition of SHM, simple harmonic motion. Acceleration is directly proportional to displacement and in opposite direction. This equation represents the relation between acceleration to displacement. If in the question mentioned the relation between acceleration to displacement, now you can use this equation. If in the question they mentioned about in terms of acceleration and time is given question, then you can use this equation. And of course the velocity already we wrote, it is in terms of time, and also we can written as in terms of displacement. We will discuss about it later. And this is a basic equation for displacement, y is equal to a sine omega t. Any doubts so far? So the simple example for SHM, it is simple pendulum. Simple pendulum is one of the best example for SHM, simple harmonic motion, right? Is a rigid support. The pendulum, it is at mean point and it is at the extreme point, oscillating. The maximum amplitude, maximum displacement, which is known as amplitude, this angle of suspension theta. So what is the displacement of SHO? Y is equals to a sine omega t. Now I'm calculating how much of time required to complete amplitude, distance of amplitude, how much of time taken by this SHO or simple pendulum to travel a distance of amplitude. Nothing but that is y is equals to a, how much of time it will take. So I'm calculating in a place of y, it is a. So a is equals to a sine omega t cancelled out, which is equals to 1 sine omega t. It is written as sine pi by 2, which is sine omega is 2 pi by t into t. Sine is cancelled. Then pi by 2, which is equals to 2 pi by t into t. Pi is also cancelled out. Then time t equal to t by 4. So the time required to travel from main point to extreme point, which is equals to t by 4. Main point to extreme point, the time taken by SHO, simple harmonic oscillator, t equal to t by 4. This is case 1. Now, what is the time taken to travel half of the amplitude? Nothing but y is equals to a by 2, right? This is case 1, mean point to extreme point, 0 to a distance. Now it is 0 to a by 2 distance. Y is equal to 0 to a by 2 distance. Same equation, displacement y is equal to a sine omega t. So I am writing here in a place of y a by 2, a sine omega t cancelled out. 1 by 2 is nothing but sine pi by 6, which is equal to sine 2 pi by t into t. Sine is cancelled. Now solving for time, which will give pi by 12 seconds. This is from 0 to a by 2. 0 to a t by 4, 0 to a by 2, which is equals to, sorry, this is time period, t by 12. Now what is the time required from a by 2 to a by 2 to a? So we know that 0 to a, it will take t by 4. 0 to a by 2, t by 12. Now I'm calculating 0 to extreme point, t by 4, 0 to a by 2, t by 12. Now a by 2 to a, how much of time it will take? So t becomes t by 4 minus t by 12. So after calculating, we will get t by 6. This is from a by 2 to a. Now one more case. How much of time required from travel from 0 to a by root 2? Why I am taking y equal to a by root 2 means at this distance the kinetic energy and as well as potential energy, the ratio which is equals to 1 is to 1. At the displacement of y by a by root 2, the kinetic and potential ratio which is equals to 1 is to 1. And why it is equals to 1 is to 1, we'll discuss about this ratio in kinetic and potential energies concept. Just here remember, at this displacement, the ratio of these kinetic and potential energies is equals to 1 is to 1. Now I'm calculating time, that is a by root 2, which is equals to a sine omega t. 1a cancelled out, 1 by root 2, nothing but sine 45 is pi by 4, sine omega is 2 pi by t into t, cancel, of course pi also cancel, then time becomes t by 8 seconds. Now you can try to calculate what is the time required to travel from a by root 2 to a distance. Try this, my dear students. So the time, I hope you done. See, the time it is becomes t by 4 and this is t by 8. So the time becomes t is equals to t by 8 seconds.